This is CPM Calculus, Chapter 3, number 153. So sketch a continuous curve which meets all of the criteria below. Alright, so f prime of x is greater than 0 for all x, okay. F of x is concave down, okay. F of 2 is equal to 1, alright. And f prime of 2 is equal to 1/2. Alright, so let's go ahead and sketch this. Oops. So my x and my y axis. Alright, so f prime of x is greater than 0. That means my function, right, if we're looking at the derivative and it's greater than 0, that means my function is always going to be increasing, right? That means f of x is increasing for all x. Because if f of x is increasing, then f prime of x is greater than 0. Alright, f of x is concave down. That means it's just going to look like this. So that means it could look like this when it's increasing, because we know it's never going to be decreasing because it's increasing. Right, so let's go ahead and erase that. We know it's concave down, so it's going like this, right? F of 2 is equal to 1. So that means we could just go ahead and label our graph, right? And we know at x is 2 here, our output is 1. Here's our x-axis, our y-axis, and this is the graph of f of x, okay? So increasing for all x, okay? Concave down means the increasing has to look kind of like this. F of 2 is equal to 1. That means this point exists. F prime of 2 is equal to 1/2. Okay, that means the slope at x is 2. Right? If I were to draw the slope line, right, it has to be 1/2. And that means 1/2 is the slope. M equals 1/2 at x equals to 2. So what's 1/2? Well, the rise over the run means 1 rise run 2. So basically the slope, right, this is the line right here is equal to y is equal to 1/2 x, right? So that means this has to be the slope at our point x is equal to 2. So let's go ahead and graph this. So this being the slope means I'm going to be going something like this and to the right, right? Going down. Let me draw this. So this is the slope here. This is all concave down, right? Alright, so this is kind of how it can look like. That means it's increasing for all x, yes. In red it's increasing. Concave down, yes, the red graph f of x is concave down. F of 2 is equal to 1, yes, this point right here at x is 2, y is 1. And f prime of 2 is equal to 1/2. So the slope at this point, right, looks like the green line, and it does, okay? So let's go ahead and answer these questions. How many roots does f of x have? So roots being how many times does it cross the x-axis? Well, if it's always increasing, it can only do that one time. Only one root. Right? Because if it hit it twice, that would mean it would have to go back up. And we know it's continuous, so it can't just be like over here too. No, because it would have to connect. And it's increasing, so only one root. What can you say about the roots? Okay, well, what can you say about these roots? So it only has one root, so let's cross out that s. What can you say about the root? Well, due to the fact that we know the slope here is 1/2, and what is happening to the slope of our function? Well, because it's increasing and concave down, we know that the slope is also decreasing, right? This means the slope is decreasing, right? So the slope is decreasing means that here at 2 it's 1/2. Over here, like eventually we're approaching 0 with our slope, right? Approaching, so as x goes to infinity, m is going to 0, right? Also, as x approaches negative infinity, m is approaching positive infinity, right? Because it has to start off at really big, right, to end up approaching 0 and be concave down. Okay, so what can we say about the roots? Well, we know the root is going to be to the left of x is equal to 2, right? It cannot be to the right of there because we have a point here, and it can't like be vertical right there because that would have an infinite slope, right? Or undefined slope. So what can you say about it? Well, it's going to be less or between x is equal to something and x is equal to 2, right? So it's going to be to the left of 2, right? Our root, where it crosses our axis, right? And also, what else can we say about it? Well, if we know that the slope here, right, is 1/2, right? And this line hits the point 0, 0, right? Our slope line at 2. And if we know our slope is going to be decreasing, right, if we go to the right, that means it has to be increasing here. And that means it can't be 1/2 here, right? So we know that this can't be a line. In red, we cannot have our graph be going like this, right? Because the slope has to be increasing as we're going toward the right, okay? So that just means that it has to be between 0, right? Between here and here. The slope at, is 1/2 here and here, or it's 1/2 here, and it has to be less than 1/2 here, meaning this root has to cross the axis between 0 and 2 somewhere, okay? So between x is 0 and x is equal to 2, that's where our root is, all right? What is the limit as x approaches negative infinity of our function f of x? Well, where is it going? We know that it's increasing. That means if we go to the left, it's going to keep going down, down, down forever. So the limit as x approaches negative infinity of our function f of x is negative infinity. Okay? Because we're going down, down, down. All right. And finally, in part D, is it possible that f prime of 1 is equal to 1? So x is equal to 1, right? Where's that point? At x is 1, here's x, so here, can our slope be 1? Well, the only thing we know about the slope is here, right? At x is 2, it's going to be 1/2. And to the left of this point, it has to be greater than 1/2. So over here, we know it's going to be greater, the slope is greater than 1/2. And over here, we know that the slope is less than 1/2. Okay, so once you pass the point of 2. Okay, because at the x is 2, we know point is equal, the slope is equal to 1/2. So can it be 1 at x is 1? Right, can the slope here be 1? Well, as long as it's greater than 1/2, yes. So, yes, as long as f prime of x is greater than 1/2 for x is less than 2. Okay, how about f prime of x at 1, can it be equal to 1/4? Well, 1/4 we know is 0.25, and 1/2 we know is 0.5. And is 0.5, is that going to be less than 0.25? No. So this one we cannot know, right? It must be greater than 1/2, and this is less than 1/2, right? F prime prime of 1 must be greater than, 1/2. Must be. Alright? Okay, and that's just because we know f prime of 2, right, has to be greater than f prime of 1. Because as we get smaller values of x, the slope function is going to be, wait, did I just say that wrong? Yeah, I did. F prime of 2 has to be less than, F prime of 1. And that's because the slope at x is 2, we know is f prime of 2 is equal to 1/2. And we know that since the slope is decreasing as we go up and to the right, the slope is decreasing, so that means it has to be bigger when this number is smaller, right? All right. So this ends looking at CPM Calculus Chapter 3, number 153.